Hello everyone. In this video, we are going to explore a new feature of LuBan. It is called projection. Let's open LuBan software. Go to File, Create, Projection. Similar as LittleFan function, the projection method works on an input image. By default, it will assume the input is a black and white image. If you input a color or a grayscale image, it will be automatically converted to black and white. Select the image, and the function will create a projection device to project that image on a screen. The set of generated objects has 4 components. You can see them by the object select or keyboard shortcut J key. It has a component called beam. This is for visualization only. And the next component, the projected image, also for visualization. You do not have to print these two. It creates a socket component, which is used to attach a light source at the back, a point light source, and a film in the front. And the last component is the film, the blue one. It has a small sized image printed in the object. If you press keyboard shortcut E, the 4 components are exploded for you to see closer. We have a positive option and a negative option. And we also have 2 types of connected shape, circle and square. And sometimes you have a light source that is square, then you can fit it into, you can select the shape, set the shape as square. The film size refers to the size of the blue film. A larger film size will make the image bigger. Film distance refers to the distance from the film to the light source. A shorter distance will make the image, the projected image, bigger. It's a simple triangulation relationship. The projection distance refers to the distance from the film to the screen. A shorter projection distance will give you a small image. A bigger distance gives you a bigger image. Socket size. Socket size refers to the size that you should measure on your light source, the size of the light source. And the light source will be fit at the back. It is the inner dimension of the socket. The socket depth is the depth of the socket. Some light source is narrow, so you can have a small depth. Other light sources might be big, so you can extend it further. The thickness parameter is used by the socket as well as the film. If you set a small thickness, both objects will be thinner. If the film has disconnected components, LuBan will generate a bridge to connect these components. And the thickness is used as the width of the bridge also. So if we set it to 3, the bridge will be bigger. The actual projection will be blocked by the bridge also, but I didn't render it on the display, just so that you know. You cannot print the whole thing connected without the bridge. The bridge has to be printed. Lastly, the tolerance. The tolerance refers to the gap between the film and the socket. If you use 3D printing to manufacture the two components, I recommend you set a negative tolerance. You will have 0.2 millimeter gap between the two. You can optionally use laser cutting to cut the film. In this case, you may want to set a positive value. If the default 0 gives you a loose connection. Let's save the object and check the output files. The output file has a number of formats, all in one. Records all in one is basically a representation of the whole thing. Then film STL and socket STL are the STL file that you can 3D print. Then if we use LuBan 2D window, we can see two other output files, SHP file and SVG file. The SVG file is basically a polygon that you can use laser cutter to cut it. And SHP file is the default LuBan format. No other software can open. It's for your own reference. This is the 2D component that you can export. And of course, you can export it into other standard vector format. Okay. And on the output folder, you also have DXF. Okay. So that is pretty much all about the projection method. As long as you keep the film size constant, you can change to different image. For example, we change to an image of a student. Last but not the least, the light source needs to be a single point light source. On the internet, if you search for LED light source, like this one, this is not suitable because it has 6, maybe I'll find a better image. What I want to show you is circular. Okay, maybe this one is. No. Earlier I have seen some good example to show you what will not work. This one. This will not work as a projected light source because it has 1, 2, 3, 4, 5, 6 LED chip LED light. The 6 light emitting unit will all shine on the film and generates 6 slightly shifted image of the boy. So you will get a blurry image, a blurry projection. So this kind of light source is not suitable. The light source that you want to use is something like this. A single light source, a single point light source or point light source. It only has a single point, something like this. That's good enough. Or maybe we can think of other things. Yeah, the T light. Maybe there are better keywords to search, but this is what I've just found. Of course, as for the strength, the stronger the better. The stronger you will get a clearer image of the projection. That is all for now. I will add more shapes into the projection method and hopefully create a useful set of tools to make 3D projection gadgets. Thank you for your attention.